Welcome to a lesson with Dr. Powell. Now, we're going to talk about what it means for the kernel of a map, especially a map defined by matrices. What happens if that kernel is 0? Well, remember that a kernel and shifts of the kernel actually kind of describe the fibers. So K is the kernel. Suppose that you have represent K as the kernel of some map. So suppose you have some map F or function F between A and B. Suppose these might be vector spaces or something. And suppose that K is the kernel. Well, A is a group, an additive group, and K is a subgroup of that. And K happens to be the fiber over 0, or the 0 element that lives in B, whatever that is, the identity of that group over there. Could be a vector, the 0 vector. Now remember that if you have a structure preserving map like F here that preserves the additive group structure, then actually all the fibers are just shifts of this one. They make up different cosets. So namely, what happens if this kernel is 0 or only has one element in it? Then every shift of it only has one element, which means every fiber has at most one element in it, which means what? Well, it means precisely, especially if this is a surjective map, then yes, all the fibers will have exactly one element in it. And if that's true, then this map will be injective. So stating that the kernel has size equal to 1 is the exact same thing as saying that F is injective, because all the fibers are just shifts of that one. Kind of fun. Thanks for watching.